So in gases, molecules or atoms are separated by large distances. There's really no interaction between them. But in solids and liquids, the particles are touchingly close. The difference between solids and liquids is the freedom of movement between the molecules or atoms. So in a liquid, the atoms or molecules can move around each other. They're still going to be close to each other, but they can move. In solids, they're fixed in positions. They're vibrating about a fixed point. So in a gas, lots of empty space, really no interaction between molecules. The forces of the intermolecular forces that hold things together are electrostatic in nature, and they depend very strongly on the distance between the atoms. With this big distance between, there's really no interaction. It's like putting something on a piece of paper on the refrigerator with a magnet, right? The magnet will stick to the refrigerator. You can put a piece of paper up, it'll stick through the paper. But if you add several pieces of paper, that increases the distance between the magnet and the refrigerator, and it won't stick anymore. If I hold a magnet on one side of the kitchen and the refrigerator's on the other side of the kitchen, and I let go of the magnet, it will not fly across the room and stick to the refrigerator. The distance is too great. The force is too weak. So here we have interactions like the magnet and the refrigerator across the room. Nothing happens. In liquids and solids, the particles are touchingly close. They're close enough that we do get a force of attraction between the magnet and the refrigerator. So here they can move around. In a solid, they're fixed in position. I'm not going to read this to you. I've kind of already said a lot of it, and you guys can read. So those are liquids. Their intermolecular forces are moderate. And then the solids have the stronger intermolecular forces. We divide solids into different categories, crystalline or amorphous. Amorphous, the prefix A means without, and morph refers to shape. So without shape. They're disordered. The particles are just jumbled together. Crystalline, they're very ordered. This might be like kindergartners sitting in rows in a classroom. And amorphous would be those kindergartners sitting on the story rug. They're not going to sit down in rows. They're just going to be all jumbled together. They're close, but they're jumbled and not ordered. Liquids assume the shape of their container because they're free to move around. And so they'll fill up the bottom and just go as high as they need to, and they'll take on the shape of their container. Solids don't do that. You put an ice cube in a beaker, and it just sits there and stays the shape of an ice cube, whereas water will spread out, right, across the bottom. Here's an illustration of water molecules in this iceberg. All these particles, these molecules are all fixed in position, but they're vibrating, okay?